Welcome back to the IC&D1 series. In this video, we will be continuing on from the previous video, and we will look at how to configure VLANs. So at the moment, the setup's going to be two switches, and we're going to have a PC connected off each switch. Okay, we're going to call these switches switch 1 and switch 2. These have got no VLANs configured on them. They've got the base configuration just configured on these. Then what we're going to do, we're going to configure VLANs 10 and 20 on both switches. We're going to put both devices into VLANs 10, see if they're able to communicate. Then after that, I'm going to put one of these devices into VLAN 20 and see, even though they're connected to the same physical infrastructure, that because they're in different VLANs, are they going to be able to communicate. So I'm going to pause the video very quickly. I'm going to bring up a console access to the first switch. So at the moment, I've got access to switch 1. To see the VLANs you currently have configured on your switch, you can use the show VLAN command. As you can see, we have some VLANs already configured on them. By default, VLAN 1 is configured on all on your switch by default, and all ports are assigned to VLAN 1. Now, that's why with switches, all ports are part of the same broadcast domain, because we need to have some VLAN configured on our switch. And the default VLAN is VLAN 1, and because all ports are assigned to VLAN 1, they're part of the same broadcast domain. Now VLAN 1 is the default VLAN for all switches, so switch 1 and switch 2 have the default VLAN of 1 configured. All the ports are assigned to VLAN 1, which means that when we connect devices to the switches, they'll be in the same broadcast domain. Now these switches, these VLANs are reserved, and they're not used anymore. So to configure a VLAN, we have to go into global configuration mode, and we simply just use the command VLAN and then number. So in this case, we can have between 1 to 4094 VLANs. In this case, I'm going to create VLAN 10. And now from this mode, we can do some configuration with it, not much, but all we're going to do from VLAN configuration mode is now change the name of the VLAN to IT. Now we're going to exit back out. We're going to configure VLAN 20. We're going to change its name to sales. So imagine that these are two different departments, and we want resources in these departments to be completely separate, but we still want to be able to use the same physical infrastructure in order to save money. And go back to privilege exec mode. Now when I do a show VLAN command, in this case I'm going to show VLAN brief, we can see that we have now two new VLANs created on switch 1, VLANs 10 and VLAN 20. Okay, but at the moment no ports are assigned to any of these VLANs. So off switch 1, I've got my PC connected to off switch 1, and that PC resides on port fast Ethernet 0/3. So in order to put port fast Ethernet 0/3 into switch 1, I have to go to global configuration mode, interface FA 0/3, and I have to use the command. First, I'm going to configure this as an access port with the switch port mode access command. Now I'm going to use the switch port access VLAN 10 command to assign this port to VLAN 10. If I use the show VLAN brief command, we can see now that port fast Ethernet 0/3 has now been assigned to the VLAN 10 VLAN. Now I'm going to move over to switch 2, and I'm going to configure VLAN 10 and 20 on switch 2 as well. So now we're on switch 2. If I do a show VLAN brief, we can see that the only VLAN on this switch is the default VLAN or default VLANs. Default VLAN 1. All ports are assigned to VLAN 1. VLAN fast Ethernet 0/1 isn't listed because it's been configured as a trunk port. And to configure switch as a trunk port, all you do is that you go into interface configuration mode and we use a switch port mode trunk command. Okay. But now to configure VLANs, as you can see, the VLANs we configured on switch 1 were not propagated to switch 2. We have to configure them manually on each switch, and so we go to global configuration mode, VLAN 10, name IT, and we can also configure VLAN 20, name sales. So as you can see, we can actually use commands. So in VLAN configuration mode, we're able to use the global command VLAN again to create another VLAN. but with this, it won't give us any help. So in this case, when you press tab, it won't finish the command for us. We're going to have to type in the whole command ourselves. If I end and go to show VLAN brief, as we can see, VLAN 10 and 20 are now created. VLAN 10 and 20 have now been created, but now we need to assign a port to VLAN 10. In this case, off my switch 2, roll over here, port fast Ethernet 0/2 connects to the other PC. So now to assign port fast Ethernet 0/2 to VLAN 10, we have to move into global configuration mode, interface configuration mode for FA 0/2, use switch port mode access command to configure it as an access port, and a switch port access VLAN 10 command to configure it as a VLAN to configure it as an access port in VLAN 10. We go to the show VLAN brief command. We can now see that FA 0/2 is now in VLAN 10. So now I'm gonna go back to switch 1, and we're going to see if now these two devices are able to ping each other. So I'm going to pause the video very quickly, and I'm going to get the machine set up with IP addresses. So now we're back on switch 1. And just before I test to see whether the VLANs are actually working properly, I'm just going to draw out again our network scenario. Okay, so we have 2 switches and a PC on each switch. Okay, we have this PC1, we have PC2, switch 1, switch 2. Switch 1 connects to switch 2 via fast Ethernet 0/2, and switch 2 connects to switch 1 via fast Ethernet 0/1. So this is a trunk port. Okay, this is used to carry traffic for multiple VLANs over a single link. Fast Ethernet 0/3 runs from switch 1 to PC1, and fast Ethernet 0/2 runs from switch 2 to PC2. So now I'm going to open up the terminal for my laptop and see if my laptop can now ping PC2. So if PC1 can ping PC2. In this case, I'm using the I'm using a 10.1.1.024 subnet, and I've given my device the IP address 10.1.1.20, and the IP address of PC2 10.1.1.10. As you can see, I can now ping that device. So the ping is well. So as you can see, PC1 can successfully ping PC2 because they're in the same VLAN. Now, another thing that I wanted to look at in this video is going to be the trunk link. To see which interfaces are configured as a trunk, we use the show interfaces trunk command. This command shows us a lot of information. Namely, the main information we want to gather from this command would be the encapsulation mode, in this case 82.1q, the status, and the native VLAN, but also the VLANs allowed over the trunk. So it lists 3 different subheadings: VLANs allowed on trunk, VLANs allowed and active in management domain, VLANs in FTP falling state and not pruned. Okay. This one lists the VLANs that are allowed over the trunk. So we can do what's called manually pruning VLANs. That's when we manually decide which VLANs are not allowed over a trunk link. In this case, all VLANs are allowed over a trunk. Now, why aren't all VLANs listed here? The reason why is this lists the VLANs that are configured on the switch and are currently active on the switch. So this is saying that VLANs 1 to 4094 are allowed over the trunk. Okay, that's if we want to configure that many VLANs. This is telling us the VLANs that are configured are active, that are configured and active on the switch. And this is what we really want to look at. This one tells us which VLANs are currently being forwarded over the trunk link. This shows us the VLANs that could be allowed over the trunk link. This shows us the VLANs that are currently configured on our switch and active on our switch, and this shows us the VLANs that are currently being forwarded over that trunk link. So when we want to look at the VLANs which are currently being forwarded over the trunk, we want to look at this VLANs. So just to reiterate again, VLANs that could potentially be allowed over the trunk link, in this case all VLANs, because we haven't limited what VLANs will be allowed over that trunk. The VLANs that are currently active and configured on the switch, and the VLANs that are currently being allowed and forwarded for over the trunk. This means that traffic for these VLANs is allowed to be forwarded over the trunk link. These are the VLANs that are currently active on our switch, and allowed over that trunk link. And these are the VLANs that could potentially be allowed over this trunk link if we configured that many VLANs. So now what we're going to do, I'm going to go onto this trunk link, conf t, interface, fh2, and we're going to mess around with the allowed VLAN list. So to change the allowed VLAN list, we use the switch port, VLAN, switch port, trunk, VLAN, right, allowed VLAN, and here we can use none, add, all, except remove. In this case, I'm going to type 10 and 20. It's best practice to only allow VLANs you have configured on your link. No, it's best practice to allow only VLANs you configured on your switch. So in this case, I'm going to only allow VLANs 10 and 20. Because it's best practice to only allow VLANs on a trunk link that need to be allowed. So in this case, if I configure VLANs 10 and 20 on this switch and on this switch, but for some reason only VLAN 10 was active on the switch, then when I configure this command, I would only list VLAN 10. There wouldn't be no need to send VLAN 20 traffic over this trunk link. In fact, it would be a waste of bandwidth. So I would just use a list allowed VLAN 10, but I'm going to allow both VLANs. Then we do a show int trunk command. Okay, we can see now that the VLANs allowed on the trunk are only 10 and 20. The VLANs active and configured on the switch are 10 and 20. And the VLANs being forwarded over the trunk are VLANs 10 and 20. So as you can see, with that command, we can change the allowed VLANs list. Now, the mistake a lot of people make with this command, they think that with this command, switchport trunk allowed VLAN, that just by typing in the VLANs, it says here that you can add VLANs. So in this case, let's say I want to add VLAN 1 again. And do show interface trunk. As you can see, it's completely overwritten the allowed VLAN list. When I type in this command, this is a list of all the VLANs I want to allow over this trunk. So if I wanted to now add, so if I wanted to add now 10 and 20, I would have to use the add keyword. So this adds VLANs onto our existing allowed VLAN list. If we do a do show interface trunk command again, it's now added those VLANs as allowed VLANs over the trunk link. Okay, switch port trunk allowed VLAN. Let's see some other keywords. Okay, so all VLANs just adds all the VLANs back to the trunk link. Do show int trunk. As you can see now, so VLANs 1 to 4094 are allowed over the trunk link. These VLANs are the VLANs that have currently been configured on the switch and are active. And these are the list of VLANs that are currently being forwarded over that trunk link. Switch port trunk allowed VLAN. Let's use remove. So if I remove 100 and 200, if we do the show in trunk command again, this shows us that the VLANs allowed are 1 through 99 and 101 through 199. As you can see, VLANs 1 and 200 have 100 and 200 have been removed from the allowed VLAN list. Switch port trunk allowed VLAN. Let's do accept. This allows all except 2, 3. Do show int trunk. As you can see, VLANs 100 and 200 are now allowed. This command says allow all VLANs except these VLANs. So in this case, we're not allowing VLANs 2 and 3 to be forwarded over this trunk link. So say that do not allow the VLANs at all, even if they are configured on our switch. So with this one, this is saying what VLANs we are allowing over this trunk link. So in this case, if I was to say store trunk allow VLAN except 10 and 20, even if VLAN 10 and 20 were configured on the switch and active, they wouldn't be allowed over this trunk link because I am pruning them. I'm saying that do not allow these VLANs. So this heading saying these are the VLANs that we can potentially allow over the trunk if they are configured and active. These are the VLANs that are active, and these are the VLANs that are active and traffic is being forwarded for the VLANs over that trunk link. So in this case, I'm just going to change it to now switch port trunk allowed B. So let me do all except. Let me do all except 10. And now we're going to see the effect of this with the ping command. So now if I do this do show in trunk command, we can see that all VLANs are allowed over this trunk link apart from VLAN 10. Now if I try to issue that same ping command, ping 10.1.1.10, the command's going to fail now. And the reason is because VLAN 10 is pruned from the trunk link. So switch 1 is not allowed to forward traffic for VLAN 10 over this trunk link because it's been pruned. And so now I'm going to allow that VLAN again. Switch port trunk allowed VLAN add 10. Do show int trunk. And before we can forward traffic for VLAN 10 over the trunk, we need to wait for it to become active and not pruned. Okay, issue this command again. It takes a while for it to become active. Now it's active. Now if I issue that same ping command, so ping 10.1.1.10, we can see that PC1 can now ping PC2 again. So we can see that by controlling what VLANs are allowed over our trunk link, we can control the traffic flows in our network. And normally, we would only allow VLANs over a trunk link if they are needed. So in this case, we may have 100 VLANs configured on both switches. But then if 50 VLANs are not active on this switch, so for 50 VLANs, if you don't have ports assigned to some VLANs, there's no point of forwarding traffic for the VLANs over this trunk link. So in our example, we have VLAN 10 and VLAN 20 configured on switch 1 and on switch 2. Because switch 1 and switch 2 have got no ports in VLAN 20 on either of themselves, there's no point of allowing VLAN 20 traffic to be forwarded over this trunk link. It's just a waste of bandwidth. Now VLAN 20 traffic would, if we did allow VLAN 20 traffic to be forwarded over this trunk link, then the broadcast packets would be sent over this trunk link and be processed by switch 2, which is a waste of bandwidth and a waste of resources. So it's better to just prune and not allow VLAN 20 over the trunk link. And also we only allow the VLANs which need to be allowed for security reasons as well. So that a rogue switch cannot connect to our network, create random VLANs. If we were to allow all VLANs, that means the random VLANs they created, they would be able to forward traffic for the VLANs in our network, wasting resources and trying to use our bandwidth. So PC1 and PC2 could pick each other. Now what I'm going to do now, I'm going to go to interface FA063, and I'm going to assign this port to VLAN 20. Show VLAN brief. Okay, as we can see, it's now in VLAN 20. Show int trunk. VLAN 20 is allowed over that trunk port. So now, if I try to ping PC2 again from PC1, ping 10.1.1.10, the ping's not going to work. So, what we can see. So PC1 has the IP address 10.1.1.20, PC2 has the IP address 10.1.1.10, and they both are in the same subnet. So even though they're in the same subnet, and they have IP addresses in the same subnet, and they are connected to the same physical infrastructure, they cannot ping each other because they're in different VLANs. They're in different broadcast domains. They would have to go through a layer 3 device in order to communicate. And with VLANs, each VLAN represents its own IP subnet. So in this case, just as an example, let me clear the space for myself. We have VLAN 10 and VLAN 20. Let's say we want to assign devices to both VLAN 10 and VLAN 20. At the moment, the subnet where the IP network we're using with VLAN 10 is 10.1.1.0/24 with a 255.255.255.0 subnet mask. With VLAN 20, we would have to put devices assigned to VLAN 20 into a different IP subnet because they are effectively in a different broadcast domain. A broadcast domain equals a IP network, and the way it works is that by default, all devices that connect to a switch are part of the same network. The reason why devices that connect to different ports of a router have to be in a different network because those devices live in a different broadcast domain. Routers separate broadcast domains, but because we're doing that with VLANs, even though we're using the same physical infrastructure, even though those devices are still owned by a single company, devices in different VLANs would have to be assigned an IP address in different subnets. So in this case, we may have to assign devices in VLAN 20 IP addresses from this network range. Therefore, they'll be in completely different networks. This is how we can. So with VLANs, we're reducing the size of the broadcast domains, but now we're starting to use more IP addresses because we need an IP address for each VLAN. That means that if we would use 100 VLANs, we would need to use 100 different IP networks within our enterprise network. So we've reached the end of this video, and we've seen how to configure VLANs is done from the global configuration mode, and we can name the VLANs. We've seen how trunk links work, and we've seen the three different headings for trunk links. So we've seen the output of the show interface trunk command. The first line lists the VLANs that could potentially be allowed over the trunk link. So that's if they were configured to be allowed. So it's saying that these VLANs are allowed over the trunk link. So if we were to configure these VLANs, they could potentially be allowed over the trunk link. The second heading lists the VLANs that are active on the switch, and the third the third heading lists the VLANs that are currently being forwarded over the trunk link. So it says traffic for these VLANs are currently being forwarded over the trunk link out of the VLANs that are active and out of the VLANs that are allowed to be forwarded over this link. I hope it's been informative for you, and I would like to thank you for viewing.